So this came out, I was asked by the organic wine growers in New Zealand to write them a small booklet on Undervine weed management. That's being one of my specialities, as Chris just said. And I rapidly realized as I got into this, you couldn't just talk about weed management and Undervine vegetation control in organic or any viticultural system without looking at the vineyard floor as a whole. So I kind of expanded out and then kind of did what's almost a kind of think piece around what does the future vineyard floor look like, and kind of then with a special bit of focus on that vineyard management at the end. So this is what we've got. There's a report out there. I'll give you the link at the end. And this is very much the kind of presentation giving you the kind of the key points and the guts of that report. And if I get my cursor on the right place. And as I'm working in the space, the kind of the context and how I view these things is, hang on, I've just lost, I need to minimize that. I very much look at in terms of farming, growing, horticulture, agriculture, in terms of the global environmental challenges we have. So all the things here, biodiversity loss, soil degradation, climate change, etc. So that old adage, we're working on our farms, but we need to think about how our farms, how our vineyards and all the rest of it impact our global environment. And a key way of looking at these things and putting the science on it is what are called the 9 planetary boundaries that were developed about 15 years ago by the Stockholm Resilience Centre and updated about 5 years ago. And they went away and had a big navel gazing exercise, and they said, okay, what are the key operating parameters of a planet? So a bit like an engine, you've got the speed, the RPM and the oil level and the water and those kinds of things. They said, what are those for the planet? And they came up with these 9 what are called planetary boundaries. And then they said, same as an engine, you know, how are these going? Are these working okay, or are they going too fast, like in RPM and over? These are the 9 planetary boundaries. And the one we typically think about is getting all the headlines. Climate change is still in this kind of zone of increasing risk, but it's by geochemical flows, too much phosphorus and nitrogen in the environment, and biosphere integrity, better known as biodiversity loss, that are the really big ones. So there's a whole bunch of these that are, when I'm working at a farm level system, I'm kind of going, how do we impact on these? So that's the context I operate in here. And so what's this Nexus idea? Well, as I worked on this report and the Undervine weed management, I realized that the vineyard floor is where a huge number of aspects of viticulture and all perennial crops come together. We've got the management of the vines, which is our primary task, but also soil, pests and diseases, and biodiversity. All these things are impacted and can be improved by how we manage the vineyard floor. And as we move from kind of the compartmentalized chemical approaches to more ecological approaches in farming, we have to start managing things as whole systems. So the big thing that came out of me working in this area is going, right, we have to reimagine how we manage the vineyard floor as a whole to address all of these problems and find their solutions. And so fairly obviously from that list, the things we want to do is have great vine performance, whether we're aiming for yield or quality in our wines and grapes. We need to improve our soil quality and health. Ideally, we want to get some pest and even disease control management out of changing how we manage the vineyard floor and the biodiversity. And so those are both for kind of internal reasons. We want to have a better functioning, more resilient, more productive and more profitable vineyard, but also addressing the environmental concerns as well. So for me, the kind of ideal system is we have plants across the vineyard floor, both under the vine and in the mid-row, that are going to improve that vine growth and health, supply nutrients, particularly nitrogen, provide us that what's called conservation biocontrol, assist with diseases, improving soil health and improving biodiversity as well. So this is kind of the package that I want our evolving vineyard floor management to achieve. And also, I see this herbicide strip as it is in most places, or this bare undervine is particularly a marketing issue. New Zealand, as a major supplier of food across the developed world, particularly to high-end markets, is very concerned about this. But viticulture as an industry as a whole is also very much consumer-facing. Your product with your label, even your face on it, may be is sitting there in front of your final consumer, and those consumers are increasingly concerned about how their food and their drink and their wine is being produced. So if you can have techniques that are improving and more environmentally friendly in here, there's potentially market advantage, or if you're not, you're potentially losing market share. And for the organic growers, so although I've come out of organics, I work across the whole spectrum of producers, but particularly for the organic guys, when I'm working with them and looking at them using cultivation tillage approaches for eliminating vegetation under the vines, I kind of look at them and essentially emulating the herbicide strip, and I kind of really ask them and say, is that really an improvement or is it not? And I think that's really far from ideal. So we really need to find some alternative approaches here. Now, the fundamental problem here for me is the Undervine strip is what it's doing to the soil there. And you can't actually kill a soil. It's incredibly resilient, but you can certainly make it very sick. And in terms of really damaging, harming a soil, it's the cropping farmers that really get the grief, because the normal ways that are considered for causing soil harm are through compaction, driving your tractors all over the place, and through doing lots of tillage, which is what the cropping farmers do, lots of. But if you look at a viticultural system or any perennial crop system with a herbicide strip, and where a herbicide strip has been in place for a number of years, 10 years say, and you go to the middle of the vine row, right underneath the wires, and you look at that soil, and maybe get a spade out and try and put that spade into that soil. That soil is really, really hard. It's really compacted. Even if you start jumping up and down on that spade, it's not going very far into that soil. The question is why? Because there's no compaction there, the usual suspect. You can't even have compaction from people walking because the wires are in the way. You know, they're always standing a foot back or so from the vine row. If it's a herbicide strip, clearly there's been no soil disturbance of any kind going on there. So the usual suspects for causing harm to soil aren't there. So why is this soil dead? Then you compare it to the center of the mid-row. So right between the two tractor wheelings, you get your spade, and assuming that you've got a sward of grass or pasture in there, and assuming the soil's moist, you'll often be able to stick that same spade into that piece of soil really quite easily. So fundamentally, why have we got this massive difference in clearly it's the same soil and the very small physical distance between the two? One of these soils is dead and very hard, and then the other seems to be really quite healthy. What's causing this difference? The answer is lack of living plants. But to understand why that's important, we need to understand something more about soil biology and what soil is. By definition, soil is a living system. The guys at NASA talk about lunar soil or Martian soil. They're talking rubbish. There is no soil on Mars or Moon. There's only regolith, what's ground up rock. Fundamentally, biology is what makes a soil. And so kind of ipso facto, a healthy soil is by definition a biologically active soil. And soil is really quite phenomenal. Again, as species that live in the atmosphere, we kind of tend to ignore what's going on in the soil, but it's the most complicated ecosystem on the planet. The rough rule of thumb is there's 10 times the amount of biomass of living things in the soil and 10 times the number of species, the biodiversity, than there is above ground. It's quite profound amount of life in the soil. The good news is in terms of making that soil biologically active and healthy is really quite straightforward. And I use this analogy of a cow. Now, a cow's a bit of a deluded beast because it thinks it's important, but it's actually not. A cow is just basically a taxi for the microbes in its rumen. A cow is basically just a big bag of microbes. Its job is to move the microbes around, provide them with food and keep them warm. And so a cow's a big bag of microbes. Your soil is basically a big slab of microbes. They're the same microbes because the cow gets its microbes from ingesting them from the plants growing in the soil that are covered in bits of soil dust and microbes. So most of the microbes in a cow are the same as the microbes in your soil. And to keep the microbes in a cow happy, we give it plant residues, or the cow supplies the plant residues kind of to the microbes. And what comes out the back end is organic matter, soil organic matter. It's kind of that simple. That's what we're doing to keep a soil biologically active. It's just a big load of really small animals, and they feed on dead stuff. So there was a really massive report came out from an organisation called Natural England in the UK about a decade ago, looking at what it takes to really get a healthy biologically active soil, to maximise soil biology. It was 300 pages long. So I summarised it along with a colleague, Molly. The link's down there at the bottom. I can summarise the summary of this in 3 key points. It's really simple. Soil needs fresh, dead stuff, whether it's plant residues, animal dung, even not on clearly on our farmlands and vineyard and stuff, fresh dead animals, but that's what is soil food. The next point is you need a diversity of food to create a healthy soil. So we can see farming systems like the maize, soya systems that produce really very large amounts of plant residues, but they're only maize and soya, and that doesn't make for a healthy soil. It's a bit like salmon is really tasty and ice cream is really tasty, but if you just ate ice cream and salmon, you'd be sick of them very quickly, and then you'd be very sick very quickly as well. Diversity is the spice of life for a soil. Unlike us, you can't overfeed a soil in terms of producing food in situ. If you import hundreds of tons of compost, yes, that's going to be problematic. But if you're just growing this fodder in situ, you cannot overdo it in terms of feeding your soil. But it's not just adding fodder to the soil. Fundamentally, it's having the plants that are producing that fodder, or the majority of that fodder, actually growing in situ. And plants are the fundamental captures of energy from the sun, and they take carbon out of the atmosphere. They take those photosynthetes and they move them down from their leaves through the stems into the roots, and they physically pump them out into the soil to feed the soil biology, and in return they get a supply of nutrients and water coming in. So they're literally pumping the sunlight and carbon from the atmosphere into the soil. So as creatures of the atmosphere, we often tend to ignore plant roots and don't think about them. We see the beautiful trees above our heads, but we don't think of the beautiful roots below our feet because we can't see them. But the root system and the foliar system of a plant is really a mirror image of each other. They're capturing the leaves, capture the light and the oxygen, pump them downwards. The roots are gathering water and the other nutrients and pumping them upwards. So living plants are effectively this way of joining the sky and the soil together. They're kind of a bridge or a zip. And so plants are actually consist mostly of carbon, oxygen, and hydrogen. They're about 90% carbon, oxygen, and hydrogen. And they get those nutrients from the atmosphere. We don't often think they're nutrients because they come from the atmosphere for free. So for me, plants are actually more rooted in the atmosphere because that's where they get the majority of the nutrients, than they are rooted in the soil. So they join the sky and the soil together, and they power soil biology. So it is living plants. If we want to maximize soil biology, we need living plants to do that. The problem is with the Undervine, there are no living plants there because we're using herbicides or tillage cultivation to eliminate these plants. So it doesn't matter how we're getting rid of them. The fundamental problem with this system is there's not enough living plants there. The vines help, but they're not enough by themselves. So from my view, the core of improving the sustainability of a vineyard is to get rid of this plant-free strip under our vines. So we have to find a better way of doing this because the current system is resulting in multiple negative outcomes, particularly around soil health and the flow-on effects from that. And so that's where this nexus comes from. We have to find a better way, and the way of doing that is to try and fix all these problems at once. It's ecology. We can't just fix one problem at a time. We need to fix them all at the same time. And so the nexus addresses a whole bunch of issues: nitrogen supply, management of other nutrients, cover crop plants to cover everything, if we do need to get rid of the plants at the undervines at some point, how are we going to do that? Biological control and biodiversity. So just like a circle, there's no starting point. I'm going to look at all these different components of the vineyard floor and just make a few comments and observations and suggestions around each of them. So first is nitrogen. If we're in an organic system where we're not allowed to use synthetic soluble nitrogen fertilizers, our alternatives are actually not very great. In organics, we often go, oh, great, we'll use some compost, but it's actually a really lousy supplier of nitrogen. And typically what happens in terms of plant requirements, not total amounts in the compost, but compared to plant requirements, there's more phosphorus and potassium in compost than there is nitrogen compared to plant requirements. So using compost to supply nitrogen will result in excess P and K being supplied. And so using organics as the lead, bagged nitrogen has multiple negative environmental effects, from its manufacturer to its application and to the downstream effects such as too much reactive nitrogen in the environment from the 9 planetary boundaries. So in my view, regardless of our farm system, organic, regenerative, mainstream, whatever, the future of nitrogen supply in viticulture in particular is from biological nitrogen fixation. That's the long-term solution. If you're going to start supplying nitrogen organically, you need to get your heads around the nitrogen cycle. And so this is the most basic version of the nitrogen cycle you need to understand as a biological nitrogen manager. All our nitrogen comes from the atmosphere. The entire planetary reservoir of nitrogen is the atmosphere, but it's in the form of what's called dinitrogen gas, N2. It's chemically completely unreactive and of no use to life whatsoever. To be useful for life, it has to be converted into reactive forms, and this is done biologically by a few handfuls of bacteria and similar organisms that can what's called fix atmospheric nitrogen into biological forms. These naturally occur in soil, but we can manipulate these by growing legumes that have formed a symbiosis with a range of these different bacteria in nodules on their roots. So we grow these legumes, we increase the number of bacteria, and we increase the amount of nitrogen fixation. So the nitrogen's fixed by these. The first form it makes is ammonia, which is a gas, and then that's converted into ammonium, NH4+. The plus means it's positively charged and it binds on the soil, so this doesn't leach. And ammonium is one of the 2 forms of nitrogen assimilated by plants. So it's taken up by plants, the plants die, they're eaten by animals, that nitrogen in the form of organic matter is returned to the soil organic matter pool. And the critical thing here is all the nitrogen on the planet is in the atmosphere. There's no nitrogen in the rocks. So unlike phosphorus and potassium and everything else that are slowly coming out of the rocks to supply the nutrients, all the nitrogen in the soil has come from the atmosphere and it's stored as organic matter. And I'll explain the importance of that in the next couple of slides. Plants can't take up nutrients in organic forms, as in organic chemistry. The molecules are too big. So they have to be mineralized, turned into inorganic forms, as in inorganic chemistry. And this is done by, again, bacteria and also fungi in this case. So they take the organic matter, break it down into inorganic mineral forms that can then be taken up by plants. And if the nitrogen cycle stopped here, everything would be great, but it continues on. Ammonium can also be converted into nitrites and then nitrates. Nitrates are the other form that can be assimilated by plants, but they're also negatively charged. So nitrates are the form of nitrogen that leaches from our soil if there is drainage, excess water in our soils. And nitrates are also the form that are denitrified, turning those reactive forms of nitrogen back into unreactive atmospheric dinitrogen. So that is the nitrogen cycle. That's the complete cycle. So if you understand that and the next few points, those are key to understanding how to manage nitrogen through biological, ecological techniques rather than relying on bagged nitrogen from the fertilizer supplier. So vines, along with all plants, only take up these 2 mineral forms of nitrogen, but there's only tiny amounts of those in the soil. The main form of nitrogen in the soil is soil organic matter. So it has to be decomposed. But we have a problem here. There's this concept called biologic zero. So as in physics, absolute zero is when all the atoms stop moving. In soil biology, biologic zero is when the biochemistry stops. And that's around 41 to 50 Fahrenheit, about 46 Fahrenheit on average. And below that temperature, all the soil organisms, including the diazotrophs, the organisms that fix nitrogen, are inactive and not doing any work whatsoever. So we end up with a situation where we've got very little mineralization of nitrogen in winter because it's too cold. Most mineralization happens in summer and autumn. And conversely, there's also little nitrogen fixation in winter, depending on your soil, winter soil temperatures. Most fixation is going to occur during summer and autumn. So what this results in, particularly in organics, where we're not using mineral fertilizers early on in the year, is we see massive nitrogen deficiency in early spring when the plants are starting to grow because the atmosphere is warm but the soil's too cold to release mineral nitrogen from organic matter or fix it, and so the plants are deficient. And for me, this is one of the classic times when using a foliar nitrogen fertilizer is really effective because you get the nitrogen directly into the leaves where it's required, whereas if you're applying mineral fertilizers to the soil, they have to be dissolved, get into the roots, and be taken up to the leaves before they can be effective. The problem is there's an awful lot of foliar fertilizers out now, particularly with the advances in regenerative agriculture that are promoting a lot of foliar fertilizers. There's products that work really well, and there's some A-grade snake oil out there in some of these products. So you really do have to be careful when you're buying any of these foliar fertilizers that there's some good independent science showing that they do work. Foliar sprays for me, however, are not a really good long-term or full source of nitrogen because the nitrogen is really expensive when you buy it as a foliar spray type. And soil biology needs nitrogen too. It's no use just putting nitrogen on the plants. All life needs the same nutrients, so you need to make sure there's nitrogen in the soil for soil biology as well. So what that all drives us towards is using biological nitrogen fixation for nitrogen supply in viticulture. The good news for this in viticulture is we have areas that don't have vines on them, the interrow where we can grow these kinds of things. But the difficulty in viticulture is, unlike virtually everybody else in horticulture who's always trying to maximize the amount of nitrogen they apply to get the maximum yield, for many in viticulture, optimum maximizing yield isn't great because that reduces grape and therefore wine quality. So depending on whether you're aiming for quality or yield and whereabouts on that continuum we are, you want different amounts of nitrogen in your system. If you've got over vigorous vines, you don't want to give them more nitrogen, you're just going to have more vigor. So it's a bit more of a tricky balancing act. So the kind of options are grow the legumes in the mid-row, and we can use mowers to move the clippings under the vines so we have a level of control of nitrogen supply, but then we're driving tractors and mowers around. There's some sense to putting the legumes under the vines because that's where the vine roots are and where they want to take the nitrogen up from, but harder to control the supply, and those legumes may compete with the vines for water, for example. So as a scientist, you'll be unsurprised to hear me go, we need to do some more research here. But globally, in terms of looking at this whole ecological approach to managing the vineyard floor, there's a great paucity of research, not just in viticulture, across all the perennial crops. So compared to the hundreds of thousands of papers done on herbicide use in vineyards and bag nitrogen use in vineyards, this kind of stuff is really desperately calling out for a whole range of research to be done. Briefly on replacing the other nutrients, in an ecological system, we need to be recycling all our nutrients. And so for me, there's no such thing as a waste in agriculture or horticulture. So the materials such as pruning and winery byproducts, for want of a word other than waste, we need to be bringing those back and the nutrients they contain onto the vineyards. Clearly, there's issues there around things such as potentially transferring diseases and stuff around. So we need to be clever about how we do that recycling. We can import fertilizers, a superphosphate or rock phosphate, typically used in organics. Compost, although I dislike compost for nitrogen supply because it's very ineffective, for replacing phosphorus and potassium, compost is really great. There's a range of other biological materials, manures and stuff. Generally, I find unless there's a really great local supply, these things are more trouble than they're worth. The other thing, if you're using stuff like rock phosphate and compost, these are all slow release materials. They release the nutrients over 3, 4, 5, even more years. So unlike soluble fertilizers where you can identify that levels are getting low and you put some on to rectify it, you need to be taking a proactive approach with these and putting them on before levels start to decline. Potassium's kind of really simple: recycle, 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 and when that fails, we've got bag fertilizers and also compost as well. And a simple illustrative analysis of what's in compost. The good news is you get a complete range of nutrients, including all the micronutrients. The problem with compost is you need to have a good local source of it, not too far away because it's expensive to transport. But where there is a good local source, I've often found on a kg per nutrient basis, compost is cheaper than bag fertilizer. And you get a whole load of free carbon and other benefits out of it. So if you are able to access compost in terms of supplying phosphorus, potassium, and all the other micronutrients, and some more carbon and organic matter into your soils, there's a lot to like about compost. And an important final point on the nutrients, globally, we've taken our eyes off the micronutrient ball. We've been very focused on NPK and magnesium and the macronutrients. And in many cases, we haven't been testing for and applying the micronutrients. And so over the decades, many of the intensive production systems across the world have become deficient in micronutrients. And there's this common mistake that because they're needed in small amounts, they're less important. This is completely wrong. They are all essential elements. And if you don't have enough of them, you're either sick or dead, whether you're a plant, an animal, or whatever form of life you are. So it's absolutely vital we're making sure we have our micronutrients at optimum levels as well as our macronutrients. Okay, I've already touched on using legumes, clovers on the vineyard floor for nitrogen supply. I now want to look at the bigger picture of other plants under the vine across the vineyard floor, that kind of generic term of cover crops, crops that are covering the ground, not being grown for a cash return. And to me, the potential here is huge, but as I said before, very little research on what's actually working. And the fundamental problem here is managing competition with the vines. The reason we've gone down the herbicide and this cultivation strip under the vines is because other plants can and will compete with the vines and cause problems such as reduced yield or insufficient water. But it's perfectly possible for vines and other perennial crops to survive and be very complementary with different undervine plants. And my favorite example actually comes from a Californian blueberry, high cane blueberry patch that I visited now many years ago. And they had two perennial weeds over there, what I call cooch or twitch. It's the rhizomatous grass that grows through the ground. And then they also had Californian thistle, which you guys probably call Canadian thistle. So that's the deep creeping thistle. And so they had these two groups of weeds, these two types of weeds in this blueberry patch. And the thistle's growing completely up through these nearly 2 meter high, 6 foot high blueberry canes and blueberry bushes. And the twitches kind of can only grow about 1 foot high at best, and it's sulking underneath the blueberries. And you'd be thinking that the Californian thistle will be the one giving, having the largest competitive effect, but it was the cooch. The thing is, it's California, so it has a huge quantity of sunlight. So even though the Californian thistle and the blueberries are competing for sunlight, there's more than enough sunlight for everybody. At the root level, which is often completely ignored in plant competition, Californian thistles have a deep creeping root, nearly 1 foot below the ground surface, and then their feeding roots go down from there. Whereas blueberry is famous for having some of the shallowest feeding roots amongst all the perennial crops. And so there is basically no interaction between the root systems of the blueberry and the Californian thistle. The spears of the Californian thistle just punch a hole through the roots and carry up into the sunlight. Whereas couch is a grass, so it has a fibrous, shallow root system, and fibrous root systems are very, very competitive indeed. So although it was being shaded dramatically by the blueberries, at the root level, the couch was competing with the blueberries very, very strongly. And this resulted in basically there was no difference in the blueberry growth where there was Californian thistle, but where there was couch, there was a foot reduction in height of these mature, established blueberry bushes. That was the level of competition. So the moral of this is we don't want to grow Californian thistle as an undervine plant because the Californian thistle is a truly ghastly plant. But what we need to do is find plants that are like Californian thistle in the fact that the root systems of the vines and the plants don't interact much or even have a possible beneficial interaction. What we don't want to be doing is almost certainly growing grasses under our vines because they will be strongly competitive unless we need to reduce vigor. In terms of putting plants under the vines, vines are a deciduous species. They're dormant for part of the year. And if a plant's dormant, there is no competition with it because it's dormant. So we can put, in theory, anything under a vine when it's dormant and there will be no competitive effect. We may actually want, when we have the vines are growing, there may be periods we actually wish to reduce growth on the vines and other periods we may want to enhance it. So we can look at having different plants under the vines at different times of year, which is one reason we may still need a way of actually killing undervine plants so we can replace them with something else. But we also need to be aware of things such as residual effects. We can easily grow a very strong cereal under our vines in winter and have no direct impact on the vines during winter. But if those cereals lock up and take up all the available soil mineral nitrogen, we will have horrendous nitrogen deficiency in spring, even if we have killed those overwintered cereals off a month or so before the vines start waking up in the spring. We've also got options around whether we have annuals and perennials. There's a load of pros and cons, and these are both for the undervine and the inter-row area as well. Perennials you establish, and with a bit of management, they kind of look after themselves. Annuals, you're always kind of establishing them, managing them, and then you've got to terminate them and then put something else in. So they're clearly a lot less work. Flip side of that is, of course, perennials have less flexibility, annuals have more flexibility. And you can still put bare earth in times. And sometimes you kind of go, we just can't afford to have any vegetation under these vines at all. That's fine. So there's a lot of mixing and matching that can be done, which is great because it's flexibility, but the problem is the combinations here are endless. So we need to do more research to start picking this stuff apart and understanding what's going to work here. There's often a concern about frost in areas that do get frosts, about having vegetation under the vines will increase frost risks. Some good studies have been done comparing short mowing undervine vegetation close to the ground and cultivating. They had the same result in terms of frost reduction, because although this cultivated soil is bare, it's introduced air into the soil, so it's insulating. But the better news was that they were both nearly as good as permanent bare soil. But again, going back to the kind of planetary boundaries working framework for all of this, I kind of go, we can't afford permanent bare soil in our viticultural systems or any of our permanent crop systems. So if frost is a problem, we can't be thinking that permanent bare soil is a solution. We need to be looking to other solutions for frost control, whether it's irrigation or windmills for moving the air around, whatever, something else, because we can't afford the permanent bare soil. So this is part of the changing conceptual framework here, kind of going, yes, this works, but the downstream problems are such we have to find an alternative. Okay, herbicide substitutes. So this was the original kind of impetus for all of this work. The organic guys coming to me and saying, yeah, okay, how do we control undervine vegetation without using herbicides? So this is it. So if you do want bare earth under your vines at some point and you don't want to use herbicides, there's two main approaches. There's the mechanical approach and the thermal approach. With each of those, we've got some subsections, and I'll just highlight each of those. But starting with the kind of the headlines, mechanical versus thermal. The mechanical options, these are generally simple-ish machines, so they're cheaper than the thermal options. Lots of people make machines for weeding and cultivating and mowing underneath vines now. Tillage is really aggressive, so it'll kill pretty much everything, but tillage damages soil. And more critically for viticulture, it's hammering your feeder roots. So when you start introducing tillage into a viticultural system where there's been no tillage before, you're going to do some significant damage to those feeder roots, and it's going to take some time for the vines to recover and adjust and move those roots lower down below the cultivation level. Stony soils, and some of our best wines come from really stony soils. Tillage is a complete disaster with those that can't cope. A lot of people think by mowing the vegetation under the vine really nice and low to the ground, they're minimizing competition. In fact, the opposite is often the case, because those mown plants are actually trying to regrow really, really hard, and therefore they're pulling nutrients and water out of the ground to facilitate that regrowth. You'll often find you'll have less competitive effect from a mature plant that's basically just turning over, rather than a mown plant that's constantly trying to regrow. And tillage approaches are also useful where you're taking a vineyard out of a herbicide strip and moving into a vegetated strip and breaking up that compacted surface and allowing the plants to re-establish. So thermal weed management, it's more expensive, particularly steam. There's a very small range of machines out there. There's no direct harm to the soil. A lot of people think about flame weeding and think, oh my God, it's going to be really cooking my soil. The soil gets far hotter from direct sun on a sunny day than it ever does from thermal weeding. Compared to mechanical, there's no damage to crop roots because there's no soil disturbance. And they can handle stones, even really big stones. But thermal weeding is a really lousy way of killing plants. It's only going to kill small dicot plants, weedlings, in one hit with 2 or 4 true leaves at a maximum. Bigger weeds and all the grasses, the monocots, are going to require multiple treatments. So thermal weeding is only equivalent to a contact herbicide. A lot of people think it has some systemic effect. It doesn't. This is in terms of flame and steam. So it's actually not even a perfect contact herbicide either. So you're having to go through time and time again if you have a lot of biomass you're wanting to kill. Looking at each of those in turn, mechanical, most of these systems now, where there's a lot of evolution of these things, particularly coming out of the organic systems, there's 2 ways of getting the equipment around the vine trunk. It's either a spring-loaded system or there is a sensor system that actuates hydraulics or pneumatic or even electronic controls to move the system. Here's a short bit of video, hoping this is working okay. This is a machine from New Zealand with a sensor system, and this is mulching. And there's some pretty reasonable work rates achievable with these machines now. So this is probably doing a good 4 kilometers an hour, which is a reasonable speed to be doing through a vineyard, especially on more narrow roads. And so here's an example of a mower. This has got a spring-loaded system. It's got a big rubber bumper around the mower head. As with all agricultural engineering, every engineer has got a different solution to the same problem, so lots and lots of variation out there. In terms of the tillage, very wide range of approaches. A traditional horizontal knife blade here. Again, both these have got sensor wand systems. And then pretty much every form of tillage tool has been repurposed for under vine and under tree cultivation. Even new stuff like this wire rope thing, there's rototillers, there's discs, there's power harrows, vertical wire systems here, a range of weed badge machines, vertical rotating discs. And I have to say, I look at that bottom photo there with the guy on the tractor and kind of look at the amount of soil that's being moved around those trees and kind of go, this is really not a long-term sustainable solution for our, in this case, under tree soil management. Interesting approach that was developed in New Zealand, no doubt coming across the world now, using a scarifying approach, so kind of a halfway house between mowing and full-on cultivation. And then we come to the thermal weeding equipment, and I have to put a small disclaimer in here. I've designed and built a whole range of thermal weeders over the year and set up a small company to sell them. And I found out I'm a terrible businessman because I get people phoning up saying, I want a steam weeder or something, and I mostly find out that it's actually not what they want. So I actually talk myself out of sales. So small disclaimer there. But thermal, the main options available at the moment are flame and steam. There's horses for courses here for different production systems. For flame weeding to be efficient and get the most effective heat transfer, the hot air has to be held on the weed for a long time, which means long hoods, which in vegetable production is fine, but in perennial crops it's completely impossible. We have the vine stems, we have the wooden posts and everything in the way. Flame weeders are also an insane fire risk. If it can catch fire, it has caught fire, and it will destroy all the plastic, irrigation pipes, etc. very, very quickly. The positive side, the machines are simple compared to steam, so they're cheaper, but they're using LPG or propane as a fuel. So in vineyards, in any kind of production, perennial production system, I don't think a flame weeder is really the right tool. Steam has the advantage is it uses the latent heat of condensation to transfer the energy in the weeds to heat them up. So you can literally fire the steam at the weeds. The heat transfer is almost instantaneous, so you don't need these big shields. It's a very low fire risk. Unless you keep firing the steam at plastic components for some time, they won't be damaged. And you can fill it up at the diesel tank just the same as the tractor, but they're more expensive and they use a lot of water. And I'll show you that how much water in a second. So this was what I call a direct fired steamer I built for a vineyard. It's 1 meter wide, designed for going down 1.2 meter rows, so really narrow spacings. And this is the steam coming out the back end. We have these little applicator, what we call socks, on the end. And you can see there's a gap of clear air between the applicator hood and the clouds of fluffy white stuff. That's actually not the steam, that's the water vapor. True steam is clear, so you can see there's a very small space, about 1 foot long, between the exit point of the steam and before it condenses. So the heat transfer is very, very rapid. The problem with all thermal weeding is the fuel consumption is absolutely diabolical. This is a 600 kilowatt steam weeder. It's using 60 litres of diesel an hour and a huge amount of water as well. So the water and fuel use is, of course, dependent on the power, how many kilowatts, how many horsepower the machine is. So the bigger the power, the more fuel and water you consume. But it does work. And this was the first trial run with that steamer in the vineyard. We hadn't quite got the sock design right, so we have a few green patches here, but it works exactly as a contact herbicide would work. And Electrothermal's not available right here and now, particularly for viticultural work for Undervine, for perennial crops, but it's a really interesting technology. So it's one of these things I want to give you a heads up on. Originates way back in the 1800s, bit of a resurgence in the 1980s, and indeed there's still commercial machines from that period available in the States. They were the Lasco brand. Uses high voltage electricity to boil the water inside weeds in situ. And so it's unique and it has a systemic weed kill. So of all the non-chemical weed control techniques I've been working with over the last 30 odd years, this is the only one that is within a QE of replacing Roundup. And there's a bit of a report on that. Just to explain that systemic action, this is how glyphosate works. We apply it as a liquid to the foliage. It's absorbed by the leaves very slowly. It travels through the plant, destroys particular amino acid synthesis system, and kills the plant. So it's systemic in the fact it travels through the plant, and it's broad spectrum because it'll kill all the vascular plants. Flame and steam and hot water as well are only like a contact herbicide. We apply them to the foliage, but if there's any growing points, any meristems that haven't been killed, they will regrow. And so for stuff like the grasses, all the meristems are in the ground. They're always unkilled, and therefore that's why grasses will regrow post a thermal treatment. Electrothermal's different. The machine is earthed in the ground, i.e. the earth, hence the name. The electricity is applied to the foliage, and it completes the circuit by the electricity traveling down through the plant stem into the roots and then back to complete the circuit of the earth. So it's systemic in that it travels through the plants like Roundup, but instantaneously instead of over several weeks. And it kills by boiling, physically turning the water in the plant into steam, so it kills absolutely everything. So for me, this is why electrothermal has massive potential in future, because it's systemic and broad spectrum like Roundup, but without chemicals. Just touching on mulches, a lot of people think, okay, we want to get out of herbicides, we'll put some mulch down to control the vegetation. You still have the problem, you've eliminated vegetation, which is the fundamental problem here. Sheet mulches, i.e. plastic sheets, annual crops, they make some sense, but longevity and perennial crops, they're also made from oil. When they're down for a long time, they start getting damaged, you get holes, so there's gaps for weeds to come in. So I really kind of, in terms of that long-term environmental sustainability, kind of look at plastic and really wonder what its viability is. And then we look at particulate organic mulches in particular, things like straw or compost or bark or whatever. Even the really kind of woody stuff doesn't actually have a very long lifespan, so you're constantly topping it up. They're an ideal place for perennial weeds like couch to get in and establish themselves. They're completely useless against creeping weeds. And particularly with that, having to replace this stuff on a regular basis, you need a good source of this. And often there's very few places you can find kind of appropriate materials that are relatively at a sensible kind of price. And even those materials that have got very low nutrient levels, if you're putting a lot of this stuff on, you will very rapidly oversupply nutrients. So they are a form of fertilizer. So again, I look at these and kind of really wonder what their long-term potential is. And finishing up with biological control. So my supervisor for my PhD, Professor Steve Ratton, developed this system for using buckwheat in vineyards to control leaf roller caterpillars. And he's basically eliminated the leaf roller caterpillar problem from New Zealand vineyards. You may well have heard of him because he's been trotting around the world at various people's expense telling everybody about this system. But conservation biocontrol is where we use the existing beneficial insects, the predators and the parasitoids to control the pests, but we enhance that system by providing the beneficial insects with the nectar and the pollen to boost their numbers and their lifespan and their fecundity, the number of eggs, etc. they lay. So 3 plants there, buckwheat, alyssum and phacelia. Steve Ratton and his students have found over the years are really some of the most effective out there. But we need to work out for any particular pest, what is the best way of achieving this. And biodiversity. Ideally with biodiversity, we would have huge numbers of all kinds of different plants, including woody plants. But of course, we have a vineyard to run, so we have limited options for what we can do before we kind of really seriously impact the vineyard. So for me, for the general improvement of biodiversity, the best place to plant a biodiverse range of plants is the mid-row. And so we're really looking at a kind of mixed species pasture, legumes, the grasses, and the forbs, the herbs as well. The problem is the typical approach to this stuff is mow it on a regular basis, but that's wrong. We need to let these things get big and go to flower and seed, but then we have problems with seed being produced in the vineyard. So there's some basic concepts here, but again, there's a whole pile of research. The obvious place to put a whole range of biodiversity plantings, different plants, is in the non-vineyard areas, the gullies and all the rest of it. But that's not the vineyard floor, and this is focusing on the vineyard floor, so that's why I'm not touching on that anymore. So let's pull all of this together. For me, for the future of sustainable viticulture, we really have to get away from these bare soil systems. So we need to have a continuous carpet of living plants on the vineyard floor. They can be different under the undervine and the mid-row, but we need to have some living vegetation there for at least for most of the years. A lot of research, but if we get this right, there's a real great win-win. We can not only address the environmental problems, but we can potentially reduce our costs, improve our vine growth for the yield and the quality, get some free biological control or very low-cost biocontrol, and get improved environmental outcomes. So this isn't a kind of, we're just going to end up paying money for this. There's potential for improving profitability and environmental outcomes at the same time. The key problem here is ecological techniques, the outcomes vary. They're very site-specific on soil and climate and all the rest of it. So at some point, as scientists, we simply cannot research all these pure mutations. You need to start becoming your own scientist and trying stuff on your own vineyards in small areas to find out what works. But you need to do this as proper science, replication, randomized. And the link there is to a small paper highlighting how to do this kind of stuff on your own vineyards and get reliable results out. So there's the link to the report. There's a whole load more information on the Future Farming website on all kinds of aspects of both annual and perennial crops and all kinds of aspects of sustainability. So thank you very much. And if I can find the chat, we can see if we have some questions.
Thanks, Murph. I have a quick question before we get to the group. Could you talk just briefly about kind of the more, I guess, experimental approaches? Like you sent me a paper on using culinary oils and also great rotational grazing.
Yep. So there's a range of work looking at culinary oils and aromatic oils as well, things like thyme oils and clove oils and stuff, that for weed control and also pest control. The problem with those, particularly in organic systems, those oils are really expensive. So I actually looked and went the other direction and looked at using some of the most common cooking oils, culinary oils. So things like oilseed rape oil, sunflower oil, rape is also canola, the same thing. And we found some really quite good weed killing effects from some of these culinary oils, not on all plants, but for me, this was one of the things for herbicides. There's been no new mode of actions of the herbicides since the 1980s when the ALS herbicides were brought in. But in terms of these non-chemical weed control techniques, we're constantly having these new ideas or old ideas reinvented and stuff like the electrothermal, or looking at just plain vegetable oil as a way of controlling weeds. So that's something easy to go and try back at home on the vineyard. Just go and get some basic, what's called RBD, refined bleached deodorized canola oil, spray it on and see what it kills.
Thank you. Does anyone have any questions for Murph?
I've got one here. So Bill's saying, are there any low-growing perennials that don't compete with vine roots that we can plant? Yes. If my starting point would be lucerne or alfalfa, as you guys call it, or red clover. So both of these have a very deep taproot on them. So the expectation would be that the taproots would be very rapidly going down through the vine feeder roots and pulling nutrients and water up from lower down rather than directly where the vine feeder roots are. And they're also nitrogen fixing, so they've got all the legumes have got, unlike grasses with a highly competitive root system, the legumes have got very uncompetitive root systems. So the vines would probably more outcompete them. Plus, both of those are nitrogen fixing species, and they've got quite big top growth on them. The alfalfa's better for dry systems. It's renowned for surviving in dry environments. It doesn't like wet feet though. So if you're running, if you're on a moister environment or heavier soils, the red clover would be my choice. It's also got a massive amount of leaves on it, so it's very good at then suppressing and out-competing, shading out other plants you don't want. And any other questions coming up?
I have another one. Have you heard of using corn gluten?
I have. I'd have to go and have a look. It's a while since I've seen the paper, so it's partly all kinds of different. Materials are being used to try and see if we can get weed control. So corn gluten's kind of just more like a kind of sticky smothering material. Another technique, guy called Frank Forsella, again from the States, he's been looking at abrasive grits. And so literally using pneumatic air supply, like for your air tools and the tire inflation, and using those to fire grits, even stuff like sand, like sandblasting they use for building and paint preparation, that kind of stuff, but also using soil, using stuff like ground up corn cobs, any kind of hard material, walnut shells, and he's been going through and absolutely kind of pulverizing weeds using this system as well. So a whole range of alternative options are continuously being developed. So those, those alternatives are continuing to come up. Okay, another question here. What's buckwheat normally used for? Buckwheat is a food crop. So buckwheat, particularly in Asia, was a more important source of flour than wheat was until until intensive agriculture came along. Buckwheat doesn't respond to nitrogen, wheat does. So we talk about buckwheat pancakes or buckwheat noodles, but it's also a very good cover crop. So it's very quick growing, and it also has an ability to extract phosphorus from the soil more efficiently than many other plants. So it'll allow you to extract phosphorus from the soil and put it into the organic pool. So a cover crop beyond its cash crop use is a major use. And another question, going to use a crimper roller to roll annual cover crop in the spring. What is the best seed to plant? Crimper rolling's a really great technique, but it's tricky because to be able to kill the plants, it has to be the right species. Not all species will crimper roll and die. They'll just come back. And the plants, all the species that it works with, they have to be in full flower, vigorously flowering, i.e. move from vegetative growth to reproductive growth before they will be killed. So if you're rolling, you'd have to be rolling autumn planted cover crops. The favorite of the roller crimper community is rye corn and vetch, and it's hairy vetch, not smooth vetch you need there. But partly the question is also, what are you wanting to achieve? So of all of those, oats I know does crimp, triticale I'm not sure about, and wheat I'm not sure about either. But you want to almost certainly want a legume. Rarely do you want to just plant a monocrop. If you're planting a cover crop or a green manure, put a diversity of plants in there. Okay, what cover crop will pull potassium up? In any kind of perennial plant system, virtually all the available nutrients are about in the top 5 centimeters of soil. That's why if you could dig up the old wooden posts, they're not treated, they're rotted around that top 5 centimeters, so 3 inches, and down below. So there is actually very little available plant nutrients in a perennial crop system with undisturbed soil more than about 5 centimeters down. So there are, in fact, very few plant species. And for me, this is one of the great myths in organics. We talk about these deep-rooted plants that are pulling up nutrients from depth. I've seen no research to justify that. And in fact, I think the opposite would be true, that the plants would actually be getting their nutrients from the surface and then sending them down into their big taproot. So I think we probably have more likely the opposite effect to that kind of traditional thought of bringing those nutrients up. Any sort of breeding for a short-statured buckwheat? No, it's quite possible there is something out there, but again, because buckwheat has fallen out of favor as a cash crop, there's been considerably less breeding going on. And what was your interest there? Because for me, a buckwheat will grow about a yard high. So if you're thinking of putting it underneath the vines, it's not going to be getting up into your vine canopy. And so you would only be able to take it from about a yard high to a 1.5 foot high, something like that, if there were dwarf varieties around. So it's not super high species. And the next question, problem with soil cover species in areas with low organic matter. Do you recommend fertilizing with bag nitrogen? Yes, if you're not organic and you're struggling to get some of those things to establish, a cover crop is still a crop. It still needs care and attention like a cash crop does. So if it's not growing because it's deficient in nitrogen or anything else, you need to make sure those nutrients get in there so the crop can go vigorously and then start fixing that soil system by growing in there. Okay, anything else? Yes, well, coming through thick and fast here.
Are there any particular animals that you would recommend for grazing that are better than others or worse than others?
No, there's been some interesting experiences in New Zealand. There was a guy here tried using guinea pigs. He's very famous. It was a guy called Peter Yealands, and vineyard is called Yealands, Yealands. And so he was trying a whole load of alternative type techniques, and he tried guinea pigs. But we have this hawk species in New Zealand, and it was very happy for the free lunch. Then he tried baby doll sheep, so this really, really small sheep, and they initially worked really well, but then they discovered how to climb up posts and climb up the stems. So they basically put their feet up onto the wires and then ate all the vines. So, and we also have to be careful where we are spraying synthetic chemicals and or copper and sulfur, because those things will be getting onto the pasture. And there are issues in New Zealand where we do use sheep, particularly over winter, for grazing the grass in vineyard and eating the leaves to destroy the load of disease inoculum. And we can have significant issues with residues, chemical sulfur and copper residues in the sheep, because they are essentially consuming the sprays. So yeah, there's some real issues there around getting the using animals in there. And okay, so how do you sow cover crops? Yeah, it's a bit of a challenge. Some people just spin the seed on and kind of maybe a bit of irrigation and hope for the best. Other people have kind of repurposed agricultural and horticultural seed drills. But there's kind of no perfect solution to that at the moment. You know, it's kind of something the engineering community and the farmer grower engineers need to be working on. And under the vine row, yes, I think of alyssum. So both Phacelia and buckwheat are really fast growing annuals. So in a vegetable crop system, that's really great. But alyssum is a perennial, and it's also evolved in a quite dry environment. So it's a really tough plant, and it's a perennial. It's also a member of the cabbage family. And I think it's slightly allelopathic. Wherever I grow it, nothing ever manages to establish underneath it. And so for a vineyard, having something like alyssum around the posts or around the base of the vine trunks, to me, has huge potential. It doesn't fix nitrogen, but it's profuse flowers, and it has profuse flowers all year round. So I would be really looking at alyssum as the starting point for a vineyard for enhancing conservation biocontrol. Can I share the oil research discussed earlier? I certainly can. It's on the Future Farming website. So you've got the big link on the screen at the moment, bhu.org.nz Future Farming Centre. If you go and have a look in there, there's an extension report in there all about the oil. In Argentina, Mendoza, we use horses during winter. Is that for grazing? Yeah, I mean, that's really interesting. And again, during winter, there's nothing on the vines, so as long as the horses aren't stripping the bark off the vines, and generally most animals don't like vine bark, unlike apple tree bark, I've found, much to my detriment, which is very tasty for lots of grazers. Yeah, it's kind of, you know, and especially if you have them to hand, it's kind of, in New Zealand, we still have a lot of sheep, so they're great things to bring into vineyards. If you don't have sheep, yeah, you know, anything else that eats the dead leaves and the pasture down, if that fits in with your system, to me, that's all great. Anything I've missed? Anything you can see, Chris or Lee?
No, I think this has been amazing and exactly what we've been looking for a few years now. And I have some of the documents that you've sent me, and I can send them to everybody, and I can send them this PowerPoint as well, so they can review it. And this week posted, the video will be posted soon. I'll edit it a little bit and send it out to everybody. And yeah, if anyone else has any questions for Murph, can they email you?
Yep, please do. Yep, just fire an email off, and I can very happy to reply.
Well, very good. Maybe we'll do this again another time for some more people.
Indeed, be my pleasure.
Thanks.
Hopefully that's been useful for everyone.
Thank you so much.